Let me put this up. Which is the best? There are 9 different flavors of M&Ms out there, and there's probably more. I don't know how many flavors of M&Ms are there. Oh, let's do that. How many flavors of M&Ms are there? There you go. I'm Googling that. Let's see. 61. There are 61 according to this one website. Some of them are special edition. The newest ones are Sheila G's Brownie Brittle M&M Minis, Keebler Chips Deluxe made with milk chocolate M&Ms. Oh, they're counting the cookies as a type of M&M because it's in a cookie. And caramel cold brew M&Ms. Most popular, wild cherry M&Ms, Mexican jalapeno peanut M&Ms. I don't know if those are most popular because I've never seen those. And special edition strawberry peanut butter. It says those are the most popular, but if I've never seen them, are they really the most popular? I don't know. What do you think is the best out of what I got on the screen? I'm not a big fan of the pretzel. I know some people like the pretzel, number 7 there. So you've had those cold brew ones, huh? I have not had those. I've not even seen those. From this list, you like the brownie ones. I see that would be the number 4. I don't know. I'm pretty traditional when it comes to my M&Ms. Of course, when I was a kid, there was 2 kinds of M&Ms, and that was number 1 and number 2. But since then, they've just added all these tons of different kinds. Peanut butter's okay. I like the number 6. But I don't vary a whole lot. I've tried the almond ones. They're all right. I've tried the pretzel ones. Don't care for them. I don't know. But yeah, it says there's 61 flavors. Crunchy mint. I have had mint M&Ms, yeah. Espresso M&Ms. See, I don't like coffee, so I probably wouldn't like the espresso one. Coconut M&Ms. Chili nut. Birthday cake M&Ms. Raspberry. Hazelnut spread M&Ms. English toffee peanut M&Ms. Honey nut M&Ms. Hostess brownies made with milk chocolate M&Ms. Cafe mocha M&Ms. White butterscotch. That's a Halloween one. Butterscotch. Interesting. Cookies and Scream. That's another Halloween one. Yeah. Milk chocolate Jedi mix. Must be a Star Wars special one then. Orange vanilla cream M&Ms. Ew, that doesn't even sound good. Don't want that. Don't want that. Morning, Dallin. We were just checking out M&M flavors, trying to figure out the best flavor. Apparently, there's 61 flavors of M&Ms. I just Googled it. I did not know there were 61 flavors. I don't think I would enjoy all 61 flavors. But like, there's a pumpkin spice latte. I'm not big into the pumpkin spice seasoning. The white chocolate, shimmery white chocolate. I'm not into white chocolate here. They are white chocolate candy corn M&Ms. White pumpkin pie. So, yeah, well, M&Ms. All right. Hope you guys had a great weekend. Let's take a look. Let's take a look at our cybersecurity lesson for the week. Oh, man. Fake student didn't turn in his attack mechanisms last week. Got to get that done. This week, cryptographic algorithms. All right, cryptograms. Let's check out the cryptographic algorithms. We're coding messages in programming, so this works well that we're doing cryptograph here in cybersecurity this week. Cryptographic algorithms. There are many important reasons companies must ensure that data sent on the internet is secure. Absolutely. All sorts of company secrets. Companies may need to send private customer information. You may need to send medical data or bank account information, passwords, home addresses, social security numbers. There's all kinds of stuff that you really don't need just made public out there. They might want to protect company secrets from competitors. They may need to comply with governmental requirements, or they just may want to keep information away from hackers, other outsiders who wish to do harm. So there are different cryptographic algorithms, the means of altering data from a readable form, also known as plain text, to a protected form, also known as ciphertext, and back to a readable form. So the best option for any situation depends on the type of information that needs to be secured. Hash functions and password storage. With hash functions, let's click the definition of that. It's a process that transforms plain text into ciphertext that cannot be directly decrypted. It's not a simple code that you can just apply. It's not A equals 1, B equals 2, C equals 3. No. Data cannot be changed back into its original form, which makes hash functions different from encryption. See, if we just did A equals 1, B equals 2, that's just encrypting something. But a hash function is beyond that. If you write to someone and use a hash function, the person will never be able to see your original message because hash functions only work one way. They're great for storing passwords, and they're used in digital signatures and cryptocurrency. So let's see. If you had the word red, the hash function might be DFCD3454. If you had the red car, the hash function would be 52ED89E8. The red car is fast would become 46042841. Look, the red car is fast doesn't resemble in any form or fashion the red car. Totally different. So it's a great way to really mix something up where someone can't decrypt it. So decode it. In these examples, the hash functions altered the data into a hash sum. Hash sums are always the same length. Notice that, yeah, from red to the red car is fast. It's still just 8 characters. And they look different regardless of how similar the original data is, because we use the same words and totally different. So benefits of hash function. The benefit of hashing is that if someone steals a hash database, they make off with only the hashes and not an actual list of passwords. It may be useless to them. Unless the hacker can reverse the hash values, they are useless. Thankfully, the number one rule of cryptographic hash functions is that they must be irreversible. They are not made to reverse, like just encoding something. Symmetric key encryption. Yeah, look at all the little electronic points of data. Encryption provides another way to keep data secure, right? Once data is encrypted, it can be sent electronically, so the receiver must decrypt the code with the private key. That's the decryption key. Okay, here's the secret. Here's how you turn this back into letters. You have to take the letter, you got to make it this number, you got to multiply it by 3, then you add 7, then divide it by 2, or some, whatever your encryption code is. The decryption key is kept private, never shared, so only the intended recipient can decrypt a message that's been encrypted with a private key. So you got to have the private key to read the data. Most encrypting and decrypting of data is done automatically by computers. There wasn't anything you'd have to do by hand. In fact, if it's done well, it'd be very, very difficult to do by hand. The sender and the receiver are usually not even aware that their data is being sent secretly because the computers have ways to do all of that. Always remember that the internet is a public network. So if you send anything that's not encrypted, it's always available for someone else to intercept the message and read it. So symmetric encryption is one of the oldest and easiest methods. A drawback of symmetric encryption is that the same key must be secretly shared. The other person doesn't have the key, it's worthless, right? Because of this, symmetric encryption is used mostly for privacy, like encrypting credit card information or data stored on a device. Did you know you can create your own secret message? No, I'm sure you knew that. Julius Caesar invented one of the earliest symmetric encryption techniques, the Caesar cipher. I think you can order the Caesar cipher at a good restaurant. Oh, that may be different. This was invented more than 2,000 years ago, and here's how simple the Caesar cipher is. If it's an A, it's a D. B becomes E. C becomes F. So all he did is just moved it 3 letters. Moved it 3 letters. A becomes D. D becomes G. G becomes J. Just move it 3 letters. That's effective if you don't know what it's doing. You could move yours 7 letters, whatever it is. See, can you decrypt this message? JRRG space MRE. So let's see. J would be G O, and then G up here is D. Good. I bet this is job, right? M is J. R is O. So it says good job. Good job. This is similar to how a computer encrypts it, but it's usually much longer. The keys, a string of characters used in an encryption algorithm for altering data, so it appears random, usually much longer. Computers don't just move it 3 letters. This is a very simple one, but effective if somebody doesn't know the key. They may think it's more complicated and really not understand. All right, asymmetric keys. How can 2 people send encrypted message back and forth over insecure channels, the internet, without meeting ahead of time to agree on a secret key? See, that's a good question. The answer is asymmetric encryption. It's also known as public key. Instead of a private key, you have private keys, there's a public key. This allows for secure messages to be sent between parties without having to agree on or share any secret key. It uses an asymmetric encryption scheme in which the encryption key is made public, but the decryption key is kept private. Interesting. So with asymmetric keys, operations are performed by 2 different but related public and private keys in a key pair. It's a computer-generated pair of a public and private key. For instance, if the public key is used to encrypt the message, only the paired private key can decrypt it. Anyone can see the encrypted message, but only the person with the private key can read it. The public key cannot be used to decrypt the ciphertext, even though it was used to encrypt it. So it's different. So let's take a look at the process of this. Step 1, key generation. Each computer must generate a pair of keys that identifies it, a private key and a public key. So the process usually just takes a few seconds to generate these keys because there's a lot of math involved because it's not just adding 3. Step 2, key exchange. The sending and receiving computers exchange public keys with each other. Here you go. Here's my key. I'll take your key. Right, through a secure channel like a TCP/IP. And the private keys are never exchanged. Those stay with the computer. So the sending computer encrypts the secret data using the receiver computer's public key. Let me give me your public key. Here, I'm going to encrypt this message using your public key and a mathematical operation. I'll send it back to you. So that you still have the private key on the other end, which is different than the public key, but is worked with a pair. So now the receiver can decrypt the message using their private key. And that's the only key that can be used to decrypt the message. It's different than the public key, but it's related in the fact you have to have it to be able to decrypt it. So very complicated methods getting out there. That's why all these hackers have to call you and try to get you to tell them this information directly, try to fool you, try to send you fake emails, text messages, whatever it is, because computer encrypting is getting pretty good. The power of public key encryption is the mathematical operation. With a one-way function, it's difficult for a computer to reverse the operation and discover the original data. Even the public key cannot be used to decrypt the data. All right, so knowledge check. How many keys are needed to encrypt the data between a sender to a receiver using symmetric authentication? I'll say this is asymmetric right here. Answer, only 1 key, right? And both of you have to have that with symmetric. Asymmetric, I guess there's actually 4 because there's 2 pairs. 2 pairs. All right, page 4. Kerberos. I don't really know how to pronounce it. Kerberos. Kerberos. Is it Kerberos? Kerberos? Let's click on the definition. This is an authentication service based on a time-sensitive ticket granting system. Oh, so these may expire. Let's see what it says about this. This is a protocol that many businesses and organizations use for authentication. With Kerberos, tickets are created to avoid strong passwords locally or sending them over the net. A ticket granting ticket, or TGT, that's a certificate issued by an authentication server encrypted with a secret key. So this type of authentication is often used for single sign-on. Kerberos uses symmetric key cryptography and requires trusted third-party authorization to verify the user's identities. Check out some of the key features. Stores passwords in a central location, making password management easy for your administrators because they're all in the same place. It provides a strong authentication protocol to enhance security by ensuring no passwords are transmitted on the network because they're all kept in the central location. They're not transmitted anywhere. This provides single sign-on capability to allow users to access different services with the same password. And it uses a powerful authentication protocol developed by MIT to enable authentication without sharing passwords on the network. So here it is. Kerberos authentication shows each step. Let's see. So here's the key distribution center, the KDC. You have the authentication server. It sends the ticket granting ticket. Number one, they send a request to the server. It sends the ticket granting ticket. The ticket granting ticket goes to the ticket granting server. From the server, gets ticket X back to them. And then that goes to server one service X. So they send a request. It comes back with this TGT. It sends that to the ticket granting server. That comes back with their ticket. And the ticket's sent to the server and back. So interesting method there. It's kind of got multiple processes to keep things secure. All right, let's look at our last page here. Knowledge check. Oh, select the best answer. What does Kerberos send to the authentication server? The key, the password, or the ticket? Well, we know it doesn't send the password, right? Because we just looked at that. It sends a ticket granting ticket, right? Let's see. That's right, because the passwords are not shared. All right, try this one. I'll let you do that one. In cryptography, what must be kept secret? The key, the cipher, or the cipher text? What are we keeping secret in cryptography?
I believe it's the key.
I think you're right. I think you guys got it. Laura's got the key also. Right, because that's how you decipher it. You don't care if everyone gets the message because it's ciphered. All right, number 3. How many keys are used in symmetric, not asymmetric, symmetric encryption?
1.
One. Let's see. Symmetric would be 1 because you share the same. The one who sends it and the one who receives it has the same single key because you share the key with the person you're sending it to. Correct? Which of the following is true of hash functions? The data can be returned to its original form. There is no key, or key is needed to decrypt the message.
It doesn't use a key, right?
Yeah, right, because you can't decipher it. That's one of the things about hashes. Correct. No keys are used because it cannot be returned to its original form. It's just stored in a hashed form, hash function form. All right, good job, guys. We have our complete the reading, understand the concepts. Let's look at the assignment for this one. There's 3 attempts. 1, 2, 3, just 5 questions, as usual. But interesting stuff. We're learning some very interesting things about cybersecurity. So if that's a field you ever considered going into, you know a lot of the key words, and just be getting in there and figuring out how they all work would be pretty interesting. So, all right, guys, have a great week. It is an A day, so I'll be here Wednesday and Friday. If anyone's got any questions, want to come by and say howdy. But otherwise, keep up the good work. You're doing super.